Okay guys, so we're gonna do essentially unit 8, day 5 today. I think I have about 2 to 3 more days in this unit that I would like to spend. And then we're gonna look at some more linear system stuff on the last 2 days, essentially like the Thursday, Friday. And I'm trying to like, again, we've like not formally been told that EQAO is canceled, so like I still have no information on that, so just so you guys know, okay? I think it is, but we just haven't been formally told, okay? So for any okay, so we're gonna look at optimizing a rectangular prism first, and then we're gonna look at optimizing a cylinder in our second part of the lesson today, okay? Which will is a nice lead in, especially if you started the activity and you have some questions about it. So for any rectangular prism with a given volume, there are always dimensions that will produce a minimum surface area, okay? So you got to think of it kind of like vice versa. So you're going to be given volume to essentially solve for surface area, okay? Or you're going to be given surface area to essentially solve for volume in that aspect. So when the length, width, and height of the prisms are equal, the front view of a prism has a square profile, okay? This prism, okay, will have a minimum surface area. So what we're saying is a rectangular prism has a minimum surface area when it's considered a cube, okay? So that's just what we're saying here. So for some of you, if you're doing a question like that, might be a light bulb moment for you, okay? The dimensions of a rectangular prism with a minimum surface area can be solved by using the formula volume equals length to the exponent of 3. Or some of you will use volume equals side to the exponent of 3. That's fine, okay? We've kind of already worked in reverse in some of these problems, so this really isn't a crazy new concept for you, okay? So again, we're just looking at, because this is a cube, we can use L on all of the sides because they are all the same, okay? The minimum surface area is produced when the rectangular prism is actually a cube, okay? Just kind of reinstating that. So let's look at doing an example, and you guys can try this out, okay? So find the dimensions of a square-based prism, okay, which is another way of saying a rectangular prism, okay, but it's saying square-based, so obviously a cube, right? With a volume of 145,000 centimeters cubed that has minimum heat loss, okay? And then B, find the surface area of this prism, okay? So for A, you're going to use your formula, volume equals L3, okay? And let's say we're going to round to 1 decimal place. Sounds good? So try that out. You guys can use your whiteboards if you want. Again, these lessons aren't going to take us very long to get through today. Pretty easy. Oh, Maggie, don't blame it on the iPhone calculator today, right? You're not using it. Would you like a regular calculator to try? You're welcome. Okay, so we sub that in, right? Did everybody get this step? Yeah. Good, thumbs up, right? Okay, then what do I do to get rid of the exponent of 3? Cube root, yes, cube root. Okay, so it's not a square root, it's a cube root. Okay, so you guys will have fancy buttons on your calculators that will either let you put in a value before the root, or you'll have an actual cube root on your calculator. Some do, okay? So if you need help with your calculator, let me know because I can help you with that, okay? And what do we get as an answer?
52.5.
52.5, excellent, okay? And centimeters equals the length. So if we had a cube here, oh, this is a lovely cube, yeah. It's great looking today. That's my cube today, guys, sorry. I even had Starbucks coffee and everything, and that's my drawing today. Okay. So what we're saying in this situation is all of those side lengths are the same, right? Okay. So now that we have all the side lengths, now what we can do is we can find the surface area, okay, or the minimum surface area for that. So surface area, so what would be the formula for surface area in this situation? What would be our surface area? How many sides of a cube? 6. And then how do I find the area of one of those sides? S squared, or we're going to use L squared in this situation just because we're saying L. Does that sound good? If you guys use S squared, I'm not going to be offended. How about let's put it that way, okay? So surface area equals 6. And what am I replacing L with in this? 52.5, okay? So surface area equals 6 times 52.5, okay? And what do we get as our surface area? 165. So 16,537.5 centimeters what? Squared. Excellent. Okay. So again, you work backwards. So we're going to look at now working at the optimizing the volume of a rectangular prism. Same concept. This time you'll be given surface area, and you'll work backwards with the dimensions. Okay? But it's the same formula. We've already seen this formula. It's nothing new. So if a given surface area of a rectangular prism, there are always dimensions that will produce a maximum volume. Okay? So the maximum volume for a given surface area in a rectangular prism always occurs when the prism is a cube. So we're just really starting to see a pattern here, right? The dimensions of a rectangular prism containing the maximum volume can be found by solving using the formula surface area equals 6 times L squared. Used that formula a couple of times already in this unit, right? So, okay, determine the dimensions of a square-based prism, just another fancy word of saying cube, okay, with a maximum volume that can be formed using 5,400 centimeters squared of cardboard. And then what is the volume of that prism, okay? So again, what formula am I going to start with to solve? Yeah, the easiest way to understand this is what are you given in your problem?
The surface area.
That's the surface area. We know that because it's right away you can even just tell because it's to the exponent of 2, right? So it's a good little hint if you're struggling to understand the question. So surface area equals 6L2, okay? I'll give you guys a second. You guys try that question out and then we'll take it up together. Yeah, you can tell them that. It's all right. Okay, so what are we plugging into surface area?
5,400.
Okay, and now all we're doing is solving equations. So the next step is to divide by?
6.
Good. And what do we get? 900. We've got some nice values here they've given us, eh? Okay, and then we notice that it's an exponent of 2, so therefore we just have to? Yeah. So 30 centimeters equals L. Okay, so again, what we're saying, let's see if I can actually draw a prism like a lot better today. Come on. Oh, nice. That one's pretty good. That one's all right, okay? I know you guys try later. Let's see, when you guys get on the iPad, let's see if you guys can do this, okay? So again, what we're saying is each of those side lengths equals 30. So now what is that volume of the prism? And so again, is it a maximum or minimum volume that we're getting established here? It's a maximum. That's right. So remember, the volume we're finding based on this will be a max volume of a prism, okay? So volume of a prism is?
27,000.
Yeah. So L3, right? So equals 3 to the exponent 3. Yeah, and you said it.
27,000.
27,000 centimeters cubed. Okay. Excellent, excellent. We can even put it again into a little bit more of a word problem if we want to. We'll do one more example just for the kids at home here. But I think you guys pretty much do have this down. I don't think this is an issue.
This is basically what the assignment is.
Yeah, well, some of the questions, some of them are a little bit different. Some of them, if you want to go deeper, right? So Helen is building a cedar chest in the shape of a square base prism with a lid to hold the blankets. She has 16 meters squared of cedar wood available. Determine the dimensions of a cedar chest with the maximum volume to the nearest tenth. Determine the volume of Helen's cedar chest to the nearest cubic meter. Okay, so for part A, okay, look at the question. What is given to you? What is that? What measurement is that?
Surface area.
Yeah, it's surface area. So you know you have to use your surface area equation. Okay? What's broken?
I cannot pull out a tissue.
It's not broken, it's you that's broken. That is, how do you not pull out a tissue?
Because it was all like.
Okay, so 16 meters squared equals 6L squared. And what we're going to do is we'll round to the nearest tenth, right, which is 1 decimal place. So divide both sides by 6. And in this operation, just because it's not as nice as our previous question, I did the square root at the same time, like this. Okay? Just because then I get that nice value instead of like having a million decimal places and then putting in the square root if you have a weird iPhone calculator or something like that. Okay? So we get 1.6 meters equals the length of this chest. Okay? Part B, again, this is very repetitive. It's fairly easy. Volume equals L3. Okay? So we take our length, 1.6, okay, to exponent 3. And this time, what's it asking us to round to? So again, you got to read your question. What is it asking you to round to? The nearest cubic meter. So what do we put as our final answer?
4.
Yes, we're putting 4 meters cubed as our final answer. Okay. Okay. So we're going to move on to the next part of the lesson. So again, it's not a crazy hard lesson. You've done these ideas before. We're going to look at cylinders next, and then I'm going to give you guys the opportunity to fill out the answers, because I actually didn't fill out my answers, so you guys are going to help me out with my notes today. Sounds good? Okay. Your page. There you go. Wait. Go forward. Little introduction to cylinders. It's like, don't be aggressive. Okay? Don't worry, you don't have to do that homework because you're doing the assignment instead.
Oh.
Okay? Yes, I know. Okay. So for a cylinder with a given surface area, a radius and height exist that produce a maximum volume. So we have the same thing. So a maximum volume can be produced. Okay. The maximum volume for a given surface area of a cylinder always occurs when the cylinder height equals the diameter. So very much like a cube, kind of in that aspect, right? We're saying that, the height and the diameter are the same. Just make sure you don't screw up your radius and your diameter, right? Okay, know the difference. So, just your typical surface area formula here is 2 pi r squared plus 2 pi r h. Okay? But the dimensions of a cylinder containing the maximum volume for a given surface area can be solved for in the formula surface area equals 6 pi r squared. Okay? So this is the formula we would actually be using for surface area. Okay? And again, you're going to be establishing the radius, but if they ask for the diameter, you would have to multiply by 2 in the end, right? When you find the r value. So SA is the known surface area, r is the radius of the cylinder, and the height will be 2r. Okay? Because if you find the diameter, you've also found the height of your cylinder. Right? Because that's what we're saying are the conditions. Yep.
Wait, so these are both the same thing basically. So we can use either formula to find surface area?
No, you have to use this one to find the maximum volume.
Oh, okay.
That's what you're trying to find, the dimensions for the maximum volume. That's what's going on here, okay? So I would like you guys to try this question. Determine the dimensions of a cylinder with a maximum volume that can be made with 728 centimeters squared of packaging. And then what is the volume of the cylinder? So you'll actually have to grab that formula out too, okay? You guys want to say 1 decimal place? Does that sound good?
Yeah.
1 decimal place for both of those questions, okay?
Okay, so So you're first gonna, oh, that's weird. Okay, so you're first, the maximum volume, maximum volume formula is 6 pi r squared, which equals the volume. Now we know the volume is 728, so we do 728.
Not the volume,
Oh, yeah, surface area, my bad. Wait. Oh, yeah, sorry. Yep, I got that right. Okay, never mind. So then you divide by 6 pi on both sides, which equals what? Can someone do that calculation for me? No? Okay. Okay, I need my...
Oh, really?
I would try to do this all in one step.
is
I would
the
try to do
volume-
Yeah.
the square root
Okay.
of 728 divided
Okay,
by
that
6
works
pi.
too.
The radius is 6.2, right? Is that right?
No, I got it. It's fine.
I'm
Then-
gonna double check the calculation just to make sure.
Wait, what do you get for the volume?
Now I'm nervous that I did this wrong. Okay, ours, it's 6. It's like 6.214, whatever. So you round that, so it's 6.2. Now, you move on to the volume of a cylinder. So the formula for volume of a cylinder is pi r squared times height, and we know that for the maximum volume, the height and the diameter have to be the same. So the diameter is 2r, so the d equals 12.4, and so now you can just fill it in. So pi 6.2 squared times 12.4, which is equal to times 12.4, which is equal to 476.7 pi, or 1497.
For A, can you just reinstate how you found the diameter and height, just so you can like repeat
Oh,
it?
the diameter. Well, if you go up here, it says that, it says that somewhere that second thing.
I did something wrong.
Yeah, so the cylinder's height equals the diameter, right? So then we know that we have to find the height. So it's twice the radius, so you just do r times 2 to find the diameter. And then you just fill it in. Okay, can you guys read that?
No.
What?
What did you get as the volume? What is that
1,
number?
4,
Why
7.
does it look like A's?
What?
4, 9.
This isn't
What
fair.
else are you missing on that?
So, yeah, units, I'll fill that out. Give me a second.
Yeah, units, come on.
0.5 centimeters cubed. Done. Stop. Okay.
Come on.
That.
Pi r squared equals right. Okay.
Those poor kids at home.
Okay, I'm sorry,
Like
guys.
they're forced to use like actual math to decipher the art.
Okay, you know what? Fine. If they can't read it.
They don't read it at all.
Yeah.
Okay.
Oh, wait.
No, I just leave it.
No, I
It's
want to
fine.
fix it. I think I broke it though.
No, hold on. What did you do to my thing?
It
Oh
popped
my god,
off.
she broke it. I just put a new one on. Okay, here you go. She broke my set. She broke it.
Yeah, in her anger, it seems.
That's alright. I'll
You
fix it
go on.
tonight. I had multiple.
Okay, so then the volume was, so the thingy was equal to, why is this broken? Oh, there we go.
It doesn't work as nice. You broke my good one.
This feels so weird.
Okay, I fixed it.
Oh, let's go.
Look at
We don't give it back.
So,
How much is
oh, there we go. Okay, so then we have 728 over 6.
No, I like
Pi.
that stylus.
So
Maybe
that's
you can buy that for me for Christmas.
this or that?
No,
See the price.
What was the answer again? Oh, this. Yeah, okay. So then it's equal to this, and then you times 2 to get diameter, and then you just fill it in, and then you get this, or
Well, that's for
this.
second generation. What about first?
Awesome.
Okay.
Thank you.
There we go.
She did it.
She did it.
I don't know how
Took us
she
7
did
minutes,
it.
but we got it. What? No. Okay. So, what about optimizing surface area of a cylinder? So, for any cylinder with a given volume, a radius and height exists that produce a minimum surface area. So, just vice versa of what we did. The minimum surface area occurs when the cylinder is like cube-like as possible.
So again, same thing.
Same idea, right? So the minimum surface area given of a volume of a cylinder always occurs when the cylinder height equals the diameter. Okay. So what they've done is they've created this equation. You can find the radius of a cylinder for a given volume with the minimum surface area by solving for r in the following formula. So volume equals 2 pi r3. Okay. So you'll need that. Write that down. Okay. So try this question out, and then I think we said Arian's going to do this one.
Yeah.
Okay.
Okay.
And this one they've given to you in liters.
Liters, interesting.
Okay. Do you think you can figure out how to do that?
Yes.
You can do the conversion.
Yes.
Okay. You could explain the conversion.
Yes.
Okay.
Wait, what do you convert?
Wait, okay.
Centimeters.
To liters?
Yeah, you can do it.
Centimeters to liters?
Centimeters cubed.
Oh, okay.
Oh.
It's typically a straight conversion.
So,
You guys might be up.
so centiliters.
Oh, so it's just 1 equals 1. Okay.
Yeah, it's not a. It's not a difficult.
Yeah. Okay.
Okay.
So I can just convert this to milliliters like straight off the bat.
Wait.
Let's do it from R cubed.
Wait, what's the formula for a cube meter? Single liter is a cube meter.
Cube milliliter.
Milliliter?
Yeah.
So how many decimal places?
2,000.
How many decimal?
Let's go 1 decimal place. Yeah. 1 cubic centimeter equals 1 milliliter.
Equals R.
Yeah, so 1 cubic liter would be 1 cubic meter.
Not.
No, because 100 centimeters is 101
Yes.
meters.
So
Yeah.
it's, I don't know, something.
Wait, so there's 1,000
That,
centiliters in
that-
1
Oh, just
liter?
convert- Okay, so then,
Yes. Yeah, you're on the right page.
Okay, okay, okay.
okay, now I can just convert it to down. Okay, there.
Volume converter.
Convert.
Yeah.
Are you ready to go?
No.
No?
I'll explain that. I'll explain this one part. Okay. So 2 liters. 2 liters. No, you can do this question. I'm just gonna explain this little part.
Oh.
So 2 liters. Okay. Okay. If we put that into milliliters, would be what? 2,000 milliliters. And we know, just so you guys know, it's pretty common knowledge. Like maybe not for you guys, but 1 milliliter, okay, is equal to 1 centimeter cubed. Okay. To give you an idea. So really, how many centimeters cubed are we looking at as a volume?
2,000.
Yeah, 2,000. Okay. Does that help you out? Now?
Yeah.
Okay, you ready to try this question now?
So now I just, wait, so surface area.
Well, first you got to use the volume, right?
Yeah.
So you determine the least amount of material required. So eventually you're going to find surface area, yes.
Yeah.
Okay, you ready? You want to come up?
Oh, I haven't found the surface area yet. Like this. Okay, so basically, volume here equals 2 pi r cubed. Okay, so then you can do like up here. You can just convert it to milliliters and then centimeters cubed right off the bat. Okay, centimeters cubed equals 2 pi r cubed. Yeah. And then you just divide both sides by 2 pi, which gives you approximately 318.3 equals radius cubed. Then you cube root that, and you get 6.8 centimeters equals R. Okay. No, it's the surface area.
What did you get? No.
Okay. That's
Okay, but maybe explain, you found the centimeters, so what is the optimal diameter and height of this cylinder,
Oh, okay. So,
right?
so the diameter and the height will be the same because it's optimal. So it's 6.8 times 2, which is 13.6. D slash height equals 13.6 centimeters. Okay? And then what you do is you just solve for surface area, right? Which
Okay,
is,
and so what's the formula for surface area of a cylinder?
isn't it 2 pi r h plus 2 pi r squared?
Yeah, so write it out.
Oh, yeah.
Write it out.
Oh, wait. Okay, how do you?
Shoot. Okay.
Yeah, that's how
There
you
you
do
go.
it. I'm just gonna erase that really quickly. I mean, yeah.
2.8 plus 2
Yeah. Now, pencil. So, what you do is you input the radius. So the surface area is, that's an equal sign, 2 pi r h plus 2 pi r squared. And then you just 2 times pi times 6.8 times 13.6 plus, this is taking so long, 2 times pi times 6.8 squared. And then you just plug in all those values, blah, blah, blah.
Let's see if he does it right, let's see if he gets all the values right.
Yeah. Did I? So then your surface area will be approximately 871.6 centimeters squared. Is that right?
Let's check, right in my computer. Yep.
Let's
Looking
go. Still better than your hand.
Looking good. Okay. I think we just have one more problem.
Yay.
Oh yeah.
But I don't think I'm gonna do it, because I think it's the same. We are done the lesson for today, so what you are working now for the rest of the period is on your assignment, okay? And if you finish your assignment with your partner, then you can work on your Desmos assignment. Okay, so there is something for you to be doing today, is what I'm trying to say. Okay, awesome. Yeah, okay.